G'day, Chris here and welcome back to Clickspring. No matter what your style of metalworking project might be, every now and then there's a need to form a precise square hole. And often the quickest and easiest solution is to simply use needle files. But another method that can give superb results is a shop-made broach. A pilot hole locates the exact position of the desired square and then the broach is forced through the workpiece. It's a cutting tool that works best with plenty of cutting oil, and it's shaped so that each tooth takes off a tiny amount of metal as it's forced through. It gradually transforms the round hole into a square of the correct dimension. If it's all gone well, then the result is a nicely sized hole with a good surface finish. Now, an attribute of this sort of broach design is that we don't need to be super precise in spacing or shaping the teeth. And that's because all of the teeth prior to the last tooth collectively prepare the opening for the final tooth to set the dimension. So within reason, we can tolerate some small errors in those teeth, providing that the very last one is correct. This gives us a bit of freedom to take a few shortcuts during the machining process and speed things along. So I'm starting with this length of 3.4mm square 01 tool steel that I've prepared off camera. It's the exact size I'd like the final square hole to be, and so it's one of the critical dimensions of the broach. It's much too long and slender to be turned between centres, so I'll need to form the features by incrementally extending the workpiece from a 4-jaw chuck. And the other key feature is the pilot diameter, which must be centred on the square. So I'm taking care to centre the raw stock prior to forming that cylindrical shape. I have the work reasonably well centred to begin with, so when I position the dial indicator, the error that I see for each jaw is quite small. I then use two chuck keys in opposition to each other to move the work, so that the dial reads directly between the original two readings for both jaws. Once it's close, I move the 0 reference to that point, so that becomes my target when I start to centre the other two jaws. Once the work gets close to being centred, the errors start to sit nicely either side of that 0 reference, and it gets much easier to pull it into position. But even doing this quickly, you can see that it will take a fair amount of time to do this for every cut. So there's a strong incentive to bypass this centering process if we can. For now though, the work is centred, so I can make a start on cutting that pilot diameter. The next step is to form the basic tooth positions, and this is where I'm taking my first couple of shortcuts. I'm just releasing two of the jaws to advance the work and then retightening them without going through the full centering process each time. Next, I'm using the first groove position to register the tool after extending the work, and then I'm using the hand wheels to advance the tool the required amount to form the next groove. Now inevitably I will have introduced a small eccentricity to each of these cuts, and the teeth won't be precisely spaced either. But as I mentioned before, they don't really need to be. Providing I don't introduce any gross errors, it's close enough for the final result, and by accepting this small error, I can move through this part of the process very quickly. Those spacing cuts have thrown up a small burr on the side of each tooth, so a few strokes on an India stone are required to tidy them up. The workpiece is then recentered in the 4-jaw chuck, this time using the much more convenient reference surface of the pilot diameter. And then the lathe is set up for turning the clearance taper behind each tooth. In this case, I'm using a taper angle of about 3 degrees. Okay, so now a quick word about the depth of cut per tooth. The total amount of metal that needs to be removed is determined by the difference between the pilot diameter and the diameter of the circle that just encloses the final square. That metal removal must now be shared across all of the teeth, so it determines how much I feed out before cutting each tooth, and that in turn ends up determining the broach depth of cut. The diameter difference also gives an indication of how many teeth are required to keep the chip load manageable. There's a bit more info on this in the free plans. Have a look in the description box below for the link. The first cut was positioned by registering the tool against the pilot diameter, and then subsequent cuts were positioned by ensuring that the tool and workpiece contacted at the same point along the bed. Now again, it's far from precise, but because of the way the teeth work sequentially to shape the hole, it'll still give the desired result. At this point, all of the features of the broach have been formed, so it can now be quench hardened. And on this occasion, I'm using the tray that I recently made for the current clock project. It keeps the broach completely covered by the boric acid glaze and almost completely eliminates the formation of black scale. The broach is hardened nicely, a quick temper to a medium straw colour, and it's ready to be put to work. In an industrial setting, a broach is far more likely to be pulled through the work rather than pushed like this. And there's a real risk of fracture using an arbor press in this way, so be sure to take it carefully. Make sure the broach is perfectly vertical before you push it through, and as always, have your eye protection on. But even with all of the compromises, it's still a great way to use home shop tools to quickly shape a precise square hole. Thanks for watching. I'll see you later. If you enjoyed this video, then here's another one that I think you'll like. I make regular project videos like the one you've just been watching, as well as videos on a longer term clockmaking project, so be sure to subscribe. If you're looking for some new projects for your lathe or mill, then take a moment to visit clickspringprojects.com, where you'll find a range of plans available for download, as well as plenty of ideas for some useful shop-made tools. And finally, if you'd like to help with the creation of these videos, then have a look at the Clickspring Patreon page. Thanks again for watching. I'll catch you on the next video.